welcome to Science Exploded. Now, today's show is all about acceleration due to freefall. That's right. So, I started to do a bit of research onto the different theories of how objects accelerate towards the ground, and I came across a theory by Aristotle and a theory by Galileo. So I decided to take a camera and go out and film some experiments to show these theories to you. In the 4th century, the famous philosopher Aristotle theorised that an object will accelerate towards the ground at a rate relative to its mass, or in other words, the heavier object is, the faster it will fall to the ground. Now, it doesn't take a genius to figure out that if I drop this brick and this small chunk of rock off a building at the same time, the brick would hit the ground first. This being the case, it isn't hard to see why Aristotle's theory was generally accepted for around 1200 years, until in the 1600s a clever man named Galileo came along and threw the entire theory of motion up in the air. Galileo's theory that objects will fall to the ground at the same rate, even though they have different masses or weights, was a radical concept in the 1600s, and could only be justified 20 years later thanks to the invention of the vacuum chamber. Now, to demonstrate these two theories to you, we've devised two simple experiments. I'm going to be showing you an experiment relating to Galileo's theory, and I'm going to be showing you an experiment relating to Aristotle's theory. As James explained earlier, Aristotle theorised that objects will accelerate towards the ground at a rate which is proportional to their weight. Now, we couldn't think of any better way to test this than drop two objects of similar dimensions off a tall building. Now, one has a very heavy mass, which is represented by the water nearly filling this 2-litre bottle to the top, and the other bottle has a very low mass, which is represented by this water just to keep it stable as it falls. Now, we're going to drop these off the top of our 3.7 metre drop, and we're going to see which one hits the ground first. Now, if Aristotle's theory is right, the heavy bottle will hit the ground before the lighter bottle. Let's see what happens. Now, as you've just seen, the heavier bottle did hit the ground first. However, this is only due to the fact that air resistance was present. The heavier bottle had more mass, giving it more momentum, meaning it can push more air particles out of the way on its descent. Okay, before we rule out Galileo's theory altogether, in the spirit of fairness we're going to have a look at what Galileo said about acceleration due to freefall. In the 1600s, Galileo announced his radical new theory. He had discovered that objects of any weight will accelerate towards the ground at a specific rate, at the same rate, 9.81 metres per second squared, or as we know it today, acceleration due to freefall. However, at the time Galileo could not prove his theory. He could only prove it when the vacuum chamber was invented in the 1620s. This is because Galileo's theory only works without air resistance, and we're going to show this to you right now. Here is a vacuum chamber that we made using some bits of wood and a hoover, and we're going to see if this Lynx can and this piece of paper will hit the bottom of the chamber first, if released at the same time inside the vacuum chamber. Okay, inside, as you can see, we already have our Lynx can and our piece of paper. All we need now is to make it a vacuum. Using this hoover nozzle, we're going to plug it into the back of the vacuum chamber. This will give us a vacuum inside this wooden box. Now, as you just saw, both the Lynx canister and the piece of paper did hit the bottom of the vacuum chamber at the same time, which undoubtedly proves that Galileo's theory is correct. However, it is only correct when the experiment is carried out in a vacuum chamber. If the piece of paper and the Lynx canister had been dropped in the open air, the Lynx canister would have obviously hit the ground first, as the piece of paper has a larger surface area, giving it more air resistance. Now, the scientific community generally accepts Galileo's theory to be the correct one. This is because it is usually so indistinguishable, the difference between objects hitting the ground, that it is generally accepted they hit the ground at the same time. Back to you in the studio. Let's pretty incredible stuff. I know, yeah, it's really amazing what a 4th century scientist figured out how to do. Right then, that about wraps up our show. Next week I'm going to be seeing if I can stick myself to the roof with a hoover. And I'm going to be showing you how you can measure the speed of light using your own microwave. Right, that's all from us, and see you next week on Science Exploding.